Hello, CIS30E. I am re-recording the videos to show you the lab as I was not able to demonstrate in the live session. So in this particular video, we're going to talk about lab 4, and lab 4 is going to use Pandas and also Numpy to build array. We are going to use Panda to create the data frame. So in the next part, I will rerun over lab 4. So as you look at lab 4, it starts with giving you the documentation. And so on here, what we want is to look at Pandas documentation, and you can click the link to be able to see that. It will take you to the user guide, and in the user guide, it gives you information, most importantly, some basic information about Pandas. Pandas is used quite a bit with Anaconda, but you don't have to install Anaconda in order to use Panda. You can use it separately. This allows us to take dataset or build data container and be able to frame it and use it for analysis and visualization. So I recommend looking through some example, and here you can see that we can use it with data structure. You can also implement it with series. Now, in some part of the lab, we will use it for IO tools. So we can have Python read the CSV file like what we've seen in the first week. And in most part, you would see that you can use it with text files. Or in the case where if you want to use it with other type of system application file, you would need to be able to implement binary like for database. Okay, so here gives you the documentation, and then if you want to learn to get started, if you have Anaconda, you would use this command to get Pandas into your system. Or if you use pip, you can use pip install Panda. Now, in the demonstration, I'm going to use Tawny, which I bring in the packages in Tawny. So making sure that you do that in your IDE. So if you're using VS Code, make sure that you install and link the packages accordingly. So in the first one, we are going to create a data frame and plot. Now, when you approach the program, if you need to be able to plot, you would need to first create data container, second to create a data frame, third, then you can use that data frame to plot or analyze. So after we install Pandas, and you can simply run this in your command prompt or your command line, or add it into your IDE, we will be able to write this program. So in Tawny, let me open up the file here. I would have the to import statement, and as I import this in, I want to make sure that I have Pandas. And so as you look, there are different type of Pandas. So if you look at, like, there's additional extension, so they give you the detail, and I'm using the latest version of Tawny. So if you install it already, it would say an upgrade or an install. So if I have it already installed, you can see that here. But if you don't have it installed, it would give you the option in your IDE to install like Tawny like this. Or you can bring it into your system if you're using idle or just your command line to program. You can use the virtual machine to do this, and you can do it directly inside the virtual machine or virtual environment. That would be fine too. So we want to make sure that Pandas is installed. We also need to make sure that our Matplotlib is installed. Okay. And so as I already installed it, it's only giving me the other options. Okay. If you don't have it installed, make sure you click install. So in the next part, what we're going to do is we are going to define and initialize the data in our data container. So here I have a data container, and this is going to be a list with nested tuple. We have the X and the Y coordinates values. So here I have 12, 24, that the 12 is going to represent the X and 24 is going to represent the Y. And so in the next section here, we are going to create an object, and this object is going to be your data frame. So you would have df, and then after that, we are going to use PD, which is our Pandas module. Okay, so we identify Pandas as PD, and we are going to instantiate this object for the data frame. So we are going to use the data frame class, and we already have the data container. So in the parameter, you want to say data is data, which is these values, and we want to specify the column X and Y. So in this case, we want to graph out X and Y. So after you have your data frame, we are going to do a scatter plot. So in our scatter plot, we simply bring down our object, which we previously defined, and we are going to use Matplotlib pyplot. So we are going to plot scatter. X coordinates is going to be X column, Y coordinates is going to be Y, or the Y X value is going to be from the X column, and the Y value is going to be from the Y column. And for the title, in the next part of the parameter, we simply give it a title, and you can title it for what your data would represent. So in this case, we're going to use a generic title called scatter plot between two variables X and Y. And lastly, we are going to use the show method. So after you define your plot, you are going to make sure that you display it. So I'm going to go ahead and run this and see that it would be able to provide me with the scatter plot. And in the scatter plot, we're simply going to put down the value for X and Y. So as you can see here, and you can use different type of plot. So if you go back to the documentation at the beginning, right, and if you click on this right here, it takes you to the Matplotlib like what we've seen before, but you can have different choices in how you want to plot. And so here it shows you can do bar and lines, and if you expand that, you would be able to look at some example. We can also go to example and tutorials to be able to learn how to use the pyplot. Okay, but simply in our code, we would do a scatter plot, which is going to put the dots onto the graph, as you would see like this. Then after we have created the first program, we're going to take a screenshot of our code and our output. Then for number 4, we're going to write the program. We're going to use Panda to build our data frame. And our data frame, our data set is going to be a 14x2 array, which contains random values. And then after that, we are going to do a scatter plot again for number 4, and we're going to provide the script. So to write the number 4, again, we're going to import Pandas. So I use import Pandas as PD. Then after that, I'm going to import Numpy. So with the Numpy, I use NP for identifier. And lastly, I need to plot. So I need to do an import Matplotlib pyplot, very similar to the previous exercise. Then I'm going to build the data container. So here I have data, and I'm going to generate random number, and I'm going to use ran n. So ran n is going to come from NumPy, and I'm going to do a 14x2. So 14 rows by 2 column, like what the exercise called for. After I have the data container, the next step is to create a data frame. And just like before, we're going to define an object and instantiate the object for the data frame class. So simply, we would specify that this is a data frame using Panda, and our data is going to be data coming from this. and we're going to have column A and B. So I decided to use a generic, but again, realistically, if you're using a specific type of data or have specific type of data, you want to specify the column here, like, birth, death, mortality, or mortality rate. You can have coordinates for geolocations, customer sales, and overall expense or tax, etc. So we want to make sure that our columns is labeled so that can be represented on the graph. Then for the next part, I'm going to go ahead and plot using scatter. So here for my X is going to be A and Y is going to be B. And I'm going to go ahead and plot. So for the next one, let me close this. And so on the next one, we're going to go ahead and run. And here now, what we have is we have a graph that will represent our random values that we generated for our data container. Now, if you want to print it, you can do a print data here to show your container. Okay, so we can go ahead and do that. So after I did that, I'm going to have my random values that I printed, and then I would have my plot. So if you want to show that you generated the random values, and every time you run it, it's going to be a little different as it is randomly generated. So you would have different graphs there, unless you seed it in the same value. So what I have is I would have my column A and B to represent X and Y. And so that's how it's able to do the scatter plot. So in the scatter plot, you want to have at least 2 columns to contain the values, so that way that you can graph it on the X and Y coordinates. Okay. So this would be a number 4. Again, we simply build our data container from our array and we shape it with 14 rows and 2 columns. Then after that, we build the data frame. We would choose to use A and B for our column name to represent X and Y. And then we would do a scatter plot. Then after you finish 4, make sure we provide the screenshot for our code and our output of our graph. Then for part B, we are going to do multiple columns. And here we already start with using 2. So we would increase our column sizes in the next exercise. So in the exercise 5, you would see the code on how we can be able to create a histogram plot with Matplotlib. And again, we need to have a data container and we need to make our frame, our data frame, and then we would do a histogram graph. So in number 5, this is the code. Again, we are going to use the same modules. Then after that, Pandas, Numpy, and Matplotlib. After that, we are going to have a data container. So we define data as an array that contains random value. And this time our shapes is going to be 4 columns and 10 rows. So 10 rows and 4 columns. Then we are going to create a data frame. So after we have our data container, and just like before, but in this case, we have 4 columns. So you need to specify your column so you can graph. And then we would do a histogram. So then after that, we would use the frame df and we would do a plot hist. And we would give it a title. Now you can add additional parameter if you want to add more details to your graph. And again, refer to Matplotlib to be able to do that. So when we run this, So here is our graph. And so we would be able to generate A as color-coded, B and C and D. Now, if you want to print out your data, again, you can just print data first to show your data. Okay, but that's not required. So if we run this again, you would see that it's going to give me my data on the shelf and then the graph. Okay. As it generates different random numbers, when you run it the second time, the graph will look different unless you tell it to see from the same value, just like before. So in this case, we're doing 4 columns so we can see the information graph on screen. All right, so this would be in the number 5, where we would have more than 2 columns, and we would use the histogram graph instead of the scatter plot. On number 6, you're given a table which contains your data. And so in number 6, what you want is you want to take this and put it into your data container. And then after that, you will be able to graph it. So we need to build the data frame after we make our data container and create a histogram plot. So for 6, we would start with, again, our libraries or our modules. So you would import those. Then we are going to build the data. Now, the way that I chose to do this is I manually set it up with the data container. Now, if you start with the 1 dimension, you can also use the shape method to reshape it to the dimension that you want, or how it would be on your assignment. So this would be 3 columns and 4 rows. So we can do a 4 by 3. But to save an extra step, what I did was I just defined it in 1 line. So here's my data. This is an array, and I used the array method to create this array. Unlike the last one where we would generate random value, we're given actual values in this one. So each of the row is going to be in a nested list or subarray. So I have a subarray that would represent each row. Okay. And since it has 3 values, that's going to be 3 columns. And after I define my data container, I would then create my data frame. So I simply define my object as df, and I'm using Panda to build my data frame. So here I would then have data frame, and my data is data from the array. And I can simply label my column. And the column in the assignment, it says ABC. So we would just say ABC. And since we are doing the plot, we would then do the data frame and would say .plot .hist. So we are going to do a histogram, and we will give it a title, histogram of ABC. Lastly, we would then display, so we would use the plot.show method. So let me clear this. And we don't need to print out the data container. If you do, you just simply print data like the last one. So when we run this, we would have this output. And so I would have 3 columns and 4 rows. And so this is represented in the histogram. After you have that, you would need to be able to output your code and your histogram graph to show that you have done the code and execute it successfully. For part C, we are going to use the CSV file, and I uploaded the CSV file on your lab page, so make sure that you download it, but you can also find additional CSV file here. Okay, for the sake of the exercise, you can use the one that I have uploaded, but if you visit this website, it will provide you with a lot of different type of data sets from California. And if you choose to use a different CSV file, make sure that you put the exact file name in your code and make sure it is CSV, and it needs to be in the same folder or the same location as your script on your computer. That's very important. So I put a little screenshot on where you can find your CSV file. And so in this script, what we're going to do is we are going to use the same libraries as what we used before. We are going to create a data frame, and that data frame is going to consist of the data from the CSV file or data set. And so on your lab, there should be a file called California Fire Parameters.csv. So you need to download it and save it in the same folder as your Python script. If you put it in the downloads folder, it's not going to be able to find it. So make sure that you copy it over to your Python script folder, okay, where you store this script. Then what we're going to do is we are going to print the first 5 rows from our data frame. So it's going to read the data set and create the frame. Then we're going to use the frame to show the first 5 rows. What I want to do is here's the CSV file. So it's going to look like Excel spreadsheet. But I want to focus in one area to make more sense of my data. So I'm interested in looking at the shape area of the wildfire in California. And so this is it's going to give me the overall how big or small the fire is going to be, right, throughout California for 2020. So I would focus on one particular column. So if you're using a different CSV file, make sure that your column name is exactly the same on your script. It should be reflective on your code as it is in your CSV file, okay? So in my CSV file, there's this column called shape area. And so therefore, I want to use that column and show it. So I wanted to read the data in that column. And I want to use that column to count the fire name and list the most common name. So I wanted to say, I wanted to define a container called fire name. And I'm going to pull that from the data frame and the column from that data frame. So as you notice, I'm using a list here because it has many elements. There are many names. So we are going to pull the column from the data set, which is the data frame. And we're going to use the value count method to be able to list it. Okay. So if you have multiple names that comes up in that column, it's going to do the count. Then after that, I'm going to print the top 10 fire name. So basically, because I have it as a container in the last line, I'm going to do a 0 through 10. So when you see the blank here, it's going to fill in the default 0. So it's going to print out the top 10 fire name. Then I would then create a data container that's going to store only the shape area column values. So now what that is it's going to use that data frame that data set to be able to create a data frame for a separate area of my program. Recall that earlier we have a data frame for our entire our entire CSV file. Now I'm going to drill down to just a data frame for my column. And that's how you can separate the subpart of your data analysis to the entire data set by creating a separate data frame. So here I have the data container, which is different than the last one. And this is going to store only the values from the column shape area. Then I'm going to build the frame around it. So I'm going to create a data frame just for that column. Okay. Then I'm going to go ahead and do a histogram plot for that. And we can be more specific in our program. So here's my fire program. So we can probably modify this and we can say, fire shape area for 2020 in California, however you want to name the title. So we're going to go ahead and run this. Okay. So if you look at my output, you would see that here it's going to read, right, my top 5 from my original data set. So the first 5 rows, so 0 to 4. And it basically gives me a little bit of the summary. So I know that it's reading the CSV file. That's for me to see that it does access this and be able to read the rows. Then it's going to print out my columns. Okay. So if I do this, I would select the shape area and it's going to give me the value for the shape area. Okay, so if you look at here, it should be reflective of these. Then after that, we are going to print out and count our names. So the next part is to look at fire name. So now we're accessing a different column called fire name. And we're going to count the ones that are repetitive. So if it's repeating, right, it's going to give me the most popular ones. Okay. So we did a value count for the common names, and then we are going to do the top 10. And the cool thing with this is it's also going to give you the data type here, right, as it outputs that. Then after that, what we're going to do is we are going to drill it down to the actual frame for just the shape area column, and then be able to plot it. So once we frame that for the shape area, right, we would be able to plot that. Okay. So here it shows you the frequency for the area. So we would see that it would be close to 500 acre for the most part. So this is a program to give you a quick run in how you can take a data set in CSV, be able to access it, create data frame from it, be able to use some of the common method to do a quick analysis and visualization with it. But you can do a lot more in applying statistic and other things to it, but this is just a very basic. So for 10, I want you to find a CSV file that you like, and you would download it and make sure that you put it next to in the same folder as your script, like what we talked about in the last one. I want you to be able to display the last 3 columns of the file. And if you don't know how to do that, you can look up Pandas, Numpy and Pandas details to be able to do that. So Pandas is going to give you a little bit of how to work with columns and things like that using Panda. Now, if you are familiar with slicing, as you took 30A, you can use positive values starting with 0 to a higher number. So for example, I can go from 0 to 5, left to right. So I can start with the first column and then go to the next column by 0, 1, 2, 3, 4, 5, and so on. But you can also start from the right by using the negative index. Okay. So if I need to go from the right side, I would start with the -1 and then go left. Okay. So I recommend look up information on Pandas to be able to find more information on how you can access the last 3 columns from the right. Then we want to display the content of those columns. So creating the data container from the CSV file, step 1. Step 2 is to be able to frame it, the entire file. And then from there, print the 3 column. Then you are going to select the column, 1 column from your data, whichever column it is, and you're going to display the content. So you can use the last template to be able to do that, as I would use shape areas. So create another container and put that column into the container and then frame it. So once you frame that column into a data frame, then you can use it to graph. And we want to graph the data however your style that you want. You can do a histogram, right? You can do a bar, you can do anything that you wish, or even a pie chart. Okay. So you would go to Matplotlib and choose your style. But if you want to stick with what we've done, you are welcome to do that. So this is the only exercise that I don't provide script for. I wanted to see how you can apply the information that you learn and how you can use your documentation, which is really easy to be able to do this. Okay. And in data science, if you pursue that, this is the very basic in the intro classes. So at this point, if we're comfortable with writing in Python, we can do that. And another language that you should explore in data science is also R. Uses similar library, or there's even shared some of the C library that's the same. And you would see that there's, the concept's the same, only the R syntax is a little different. So what you want to do is you want to go through the steps here and implement that into your algorithm and be able to output your code. And what I want to see is a screenshot of your script and your output, including the graph. Okay. So if you have any questions, make sure that you contact me. If you come across error, please submit a message with the error message, a screenshot, and also include some information about your code, like at least the entire file, or give me copy and paste your code into the message so I can see what you wrote and why it's giving you an error, so I can help you troubleshoot it. Okay. But if a lot of the times it's either you don't have the modules and the packages installed properly, or if you don't have your Python path set up properly. So make sure that you add the right path. And then in the case that if you have Tawny error, I came across that. So when I uninstalled Anaconda, it took away some of the things. And so what I did was I just installed a new version of Tawny, and it's able to, and then I reinstall the packages on it, and it should be able to work. Okay. So sometime when you uninstall related software, it takes away some of the basic dependency for your packages. So and that create additional problems. So what you want is you need to reinstall the software or update the software. So in Linux, this is why we always tell you to do an update whenever you uninstall or install new software. So that way we would bring in all the necessary packages. Okay, so it's always a good practice to, and then if you install the packages, sometime like on an IDE, you might want to reopen the IDE and that particular project. It's going to update it because sometimes it doesn't always update it at once. So you want to make sure that we would then get it updated after we reopen it. So you got to restart your IDE. Okay, so that's basically covering Lab 4 for CIS30E. If you have any questions, please feel free to contact me. And thank you for watching this video. I hope I can give you some explanation and demo in this video. Have a good night.